Hey everybody, it's Jay Henry. I am here working on a computer vision model. In the last video, we kind of set up the project and created training data for training a computer vision model to recognize different stages in plant growth for a project that I'm working on at home, growing some plants indoors. And I need a visual model to monitor it and let me know when certain plants reach certain stages of maturity so that I can feed them, transplant them, etc. In our last video, we took some raw video data and converted it to image data and kind of extracted the images from the videos so that we could feed them into a neural network to train a vision model. So what I want to do today is create an image data generator to further enhance our training model and do some cool stuff like skew it, flip it, rotate it, and just get us a more diverse training set. And the way that I'm going to do that is I'm going to use an image data generator, which is built into Keras. Keras is a machine learning framework that provides a high level abstraction over the lower level construction of a neural network. Allows you to be very declarative in the architecture of your network, which is kind of the level I want to work at. But also provides some great utilities and has the nice side effect of being able to run on AMD GPUs, which is what I have. And I'll show you how to do that. It doesn't work with my GPUs don't work with CUDA because they're not NVIDIA, so I had to do a couple of hacks to get them to work. But anyway, today I'm going to create the image data generator, and we're going to parameterize it to take in a directory of images for training and give it some parameters to tell it how to treat those images, how to manipulate them to give us better training data, and then we'll also create a validation image generator which will be used as the model is training to see how good a job we're doing in training it. So getting right to it, I like to be pretty descriptive in my structure so it's easy for me to find things. I'm going to create this is going to be in Python, by the way. I'm going to, and I should put step 3 here. Step 3, generate training data, which is, slightly different than getting data. We're going to actually generate it. So under the generators, I'm going to create a file, and I'm going to call this, I don't know, I'm going to call this, it's going to be pretty generic. I'll call it model data generator.py. And in here, I'm going to import the OS because we're going to be doing things with files, I think. We may or may not need that. Oh, and then with the environment, that's why we import that. Environ, and so we're going to tell it what kind of backend to use for Keras. Keras typically is used with low-level machine learning libraries like TensorFlow, CNTK, things like that. We're actually going to use something called PlaidML. And the reason we use plaid.ml or plaidml is, again, because it is compatible with my AMD GPUs. If you have NVIDIA GPUs, you don't need to use this. You can just use TensorFlow or something else. But again, my AMD GPUs just won't do that. So I have to use plaidml, which is actually a really great library, and I will link it in the description below. So I'm going to need to import some things from Keras. And we're doing pre-processing here, so it's from the pre-processing namespace. We're going to import image data generator array to image. Yep. Image to array and load image. Okay. And then I'm going to define a couple of methods here. We're actually going to import this into another module that's actually going to do the training. So I'm going to create some functions here that we can use to get our image data generated. And so the first method I'm going to create is going to be called create generators. And it's going to take in a batch size. This will be the number of images to process at one time. I'm going to give it a train path. This will be the path to the images to use for training. Validation path for validation images. And then target size. This is going to be the scale of the images once they are rescaled. It's going to rescale the images down to make them, more memory efficient. You might want to use very large target sizes if you are, building something like a GAN where you want to generate high-resolution images. But I think for this effort, a smaller target size will work. And so I'm going to create another couple of helper methods. One, create train gen with batch size. And what this is going to do is actually create the image data generator with some parameters that tell us how we want to manipulate the data as we're processing it. So let's say train gen equals image data generator. That looks right. And let's add some parameters. So the first one is going to be rescale, and rescale is not actually going to rescale the image, it's going to rescale the values for each pixel. When you're working with neural networks, there's a lot of science and data behind the fact that you want to have values that are normalized between -1 and 1, I think it is. And so what this is going to do is actually rescale them. Because pixel values are between 0 and 255, it's going to rescale them, I think, between 0 and 1. And so we need that. We're going to do a shear range. And this, shear, is that right? Is it spelled right? I think it's spelled right. And this is going to tell it how much to shear the images, so it'll skew them, so that we get, again, more variability in our images. We're going to do a zoom range. Same thing, it'll zoom in and out of images so that we get, close-ups of sections of the images so that we can find those features. And then horizontal flip equals true. Sometimes it'll flip them, and we'll get, again, pictures of upside down stuff that we didn't provide upside down pictures for. And we'll return that. And then we're going to do something very similar for the validation gen. Create val gen. These are short method names because they're going to be used internally, and you're always going to have context. It's not, an API type of naming. We'll say val gen equals image data generator, and for this one we're just going to do the rescaling of the pixel values. Don't need to shear, zoom, or flip. You know what, we can actually do a tail call here and save ourselves a little bit of memory. I'll just return this. I think that should work. Yep. We don't need to shear, zoom, or flip our validation images. We want them to be our actual images. So we're not going to add those parameters. So what we'll do in here is we'll say train gen equals create train gen. We'll pass in our batch size. And are we actually even using that? You know what? We're not using that. We don't need to pass that in. That is unnecessary. So we'll create train gen, and then valgen, we'll create valgen. Again, very short names. They're only used in the context of this file. So, if I was building an API with these, I would make them very descriptive names so that people who are not familiar with them would have an intuitive understanding of what they do. We're going to call these train data gens, because the train gen itself is going to be the train datagen dot, and then we're going to flow from a directory. And this is where it's actually going to reach into that directory and grab those images, and it's going to, from each subdirectory, infer that that is a class that we want to train to, and it'll actually, as part of this data generation, will provide the one-hot labels, I think they're one-hot labels, that we need in the model to determine what's what. So that's kind of cool and saves us some time. So I'm going to feed in the train path. I'm going to treat target size equals, I'm just going to call it target size, right? That's what we passed in. And then we're going to do, here's where we use batch size equals batch size. And then we'll do class mode. And class mode is going to be categorical, because we're trying to categorize these things that we are training it for. And then we'll say that valgen equals val datagen, and then again flow from directory. Same arguments, really exact same arguments. So we're just gonna copy that, and then we're gonna return the train datagen and the val datagen. And again, the only reason we have two of these and we don't just use the sorry, we're going to return these. The reason we have two of these and not just one is, again, because the val data generator is not going to shear, zoom, or flip our images. And then this is kind of exactly what we need this to be. I think, let's go ahead and wire it up, and then maybe in the next video we'll get down to the actual building of the model. I think that makes sense. So I've already got a model trainer here that's going to call these generators. So do some of the same stuff. We'll import the OS, and again, this step, it's not really necessary if you have NVIDIA GPUs, or if you just want to use your CPU to train. I mean, I think that's fine too. Be a little slower, but for me, with my AMD GPUs, I need to use Platinum. Keras.backend. Another reason I really like using Keras is you can, swap out your backend. So if you find one works better for you, or one has better performance, or you just like it more, I guess, you can easily swap it out without changing your Keras code at all. Maybe a little bit. And then we'll import our generator here. Generators, and then we'll import model data generator as generator. I think that'll work. And then let's declare some of our parameters. So we'll say batch size equals, like 16 is a good image batch processing size. We're going to have some other parameters later, but for now we'll just do what we need here, and I'm going to do some fairly low res images. I'm going to size them down to 64 by 64 before we process them, because it's just more memory and efficient, right? Again, if you wanted to do high res images, you might scale them to 4096. I don't know, but we don't need that right now. All right, and I'm going to create a method train plant, which first of all, I'm going to take caps lock off. Train model, right? Because the type of the model is in the name of this file. It's the plant maturity model. So we're going to say train model, and we're going to right now just get our data generator. So we're going to say train gen val gen equals generators dot create generators, batch size, and then here we're going to give it the path. And I think we're at the top level, so we'll go data, and we'll go train, and we'll go plant maturity, and that's all we have to give it. So if we look at it, under here, plant maturity, we've got these two subdirectories. It's going to automatically infer that these are two different classes that we want to train for. And you'll see when we start running the model that it'll actually tell us, hey, I'm training for two classes. We're going to tell it the validation path. Validation, plant maturity, and again it's going to do the same thing. It's going to say, okay, well, you've got juvenile and seedlings under here. I'm going to use each one of those to test your model respectively, and then we're going to give it our target height and target width. Now we're passing in the size here as height, width. They're both the same, so it doesn't matter. I'm not actually sure if width should come first, and if they were to be, if it was to be like a 3-to-1 image ratio, you might want to make sure, but it doesn't matter right now because they're both the same size. All right, and then can't do anything else just yet because we have to create the actual model and then feed this into the model. So I think what I'll do is just commit my code and push it, and then in the next video we'll actually build the model that we're going to train. And the model we're going to train is going to be a ResNet image classifier, which has got some neat properties that I'll talk about in that video, but for now I think I'm just going to add these. So let's get status. We're going to need to get add all, get status, and yep, they all got added. Get commit am, and adding data generator module to enable easy loading of training image data. Go ahead and push that up. And again, once we get a CI/CD pipeline in place, we obviously do feature branches and pull requests. We don't have that right now. Sole developer environment, doesn't really matter. And we'll push that up. So that's it for now. If you found any of this useful, please like and subscribe. And then in the next video, we'll do the model generation and training. If you have any questions, please leave them in the comments. I'll try to get to them. And if I did anything wrong, please let me know that in the comments as well, so that I can learn some stuff. Thank you all for watching. I hope you enjoyed it. See you next time.